Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, we're going to talk about the lifetime of object references and how the .NET runtime manages the memory that your objects use. And we'll talk about constructors, which are special methods that fire off whenever you create a new instance of a class. And finally, we're going to talk about static methods and properties. So first of all, let's create a new console application called Object Lifetime. And so I want to recreate part of the car example that we used in the previous lesson. So I actually have it on my clipboard. I'm going to just paste it in here and pause the video if you need to catch up, but make sure that you've created the car class. You can practice that prop tab tab, enter enter technique in order to create the properties if you like to. Just go ahead and pause the video, and before long you should have what you see here on my screen. And then the next thing we'll want to do is create a new instance of the car class like we learned about in the previous lesson. So let's go car my car equals new car, like so. Great. Okay, so let me ask you, what is happening whenever this line of code is actually executed? The car, my car equals new car. Well, the .NET Framework runtime has to go and create a spot in the computer's memory large enough to hold a new instance of the car class. So the computer's memory has addresses similar to street addresses of your home, where it temporarily stores values during the lifetime of a variable, or in this case, of an object. So the .NET Framework creates a place in memory large enough for the particular data type, in this case, an instance of this class, of the car class. It takes note of the address where it put that new instance of the car class, and then it serves that address back to you, the programmer, so that you can get back to that information in memory. And you store that reference in your variable, in this case called my car. Okay? So my car simply holds an address, a reference to the instance of the car class in the computer's memory. Whenever you need to work with that instance of the car class, you just use the my car identifier, and the .NET Framework takes care of the rest for you. It gives you the illusion that you're actually working with the object itself, but in reality you're just holding on to a reference to an address in the computer's memory. Okay? So an analogy that helps me understand references to objects in memory is kind of the handle of a bucket. We've used the bucket analogy several times up to now. When you store an object in memory, .NET gives you, the developer, a handle so that you can hold on to the bucket. If you let go of the handle, you'll no longer be able to retrieve the bucket. The bucket will no longer be accessible. But why will it no longer be accessible? Well, the .NET Framework runtime goes through and cleans up memory every once in a while by counting references. If we're no longer holding on to a reference to that instance of the car class, then we'll remove the data that's stored in that spot in the computer's memory and freeze it up so that other programs can use that address in the computer's memory for their own needs. And this process is called garbage collection. So you can do something like this, like we've already done here, where car my car equals new car, and then you'd set properties and do all kinds of stuff like that here, and then you could do my other car equals my car. Okay, and so now you have two references to the same object in memory. Notice that in this second case, I didn't create a new instance of car. I just set it equal to the instance of car that we created previously in line number 13. So now you have two references to the same object in memory. We essentially attached a second handle onto that same bucket so that we can use either one to retrieve data in the bucket, so to speak. So another analogy, it's like the string to a balloon. After you cut the last string holding the balloon, it floats off in outer space and you never hear from it anymore. You never see it again, okay? Well, as the references go out of scope, in other words, when the current thread of execution leaves the code block where the variable or object's in scope, or those object references are set to null intentionally by you, the programmer, then the number of references to the object. The number of handles in the bucket go to 0, and that's known as a reference count. And then at some indeterminate time in the future, the .NET Runtime's garbage collector feature will go around and it will look at each object in memory and it will remove those objects from memory that no longer have anything pointing to it, any references to those objects in memory. They, in essence, empty the garbage buckets out, and that memory can then be used for some other purpose. So in this case, we could explicitly set our object references to null like so. So my other car equals null, and then my car equals null. And then at some point, the object references, once it hits those lines of code, at some point in the future, the object that those variables reference will be removed from memory. When does it happen? Well, whenever the .NET Framework gets around to it, okay? In some situations, this indeterminate period of time can pose a problem, especially when the object in memory is holding on to a system resource like a reference to a network connection or a file on the file system, or holding on to a handle to access the database. In these cases, you want to take a more deterministic approach to requesting that .NET removes the object from memory and, if necessary, finalizes any cleanup procedures that might be required. So in these cases, you want to learn about a term called deterministic finalization. However, that's a little bit more advanced, and we're not going to cover that in depth here. However, a quick search on the internet will provide plenty of discussion about what it is and the scenarios where it'll be important. All right, so let's talk about that first line of code, line number 13, once again. My car equals new car. So there's something subtle about this that might not jump out at you right at first. Notice that there's parentheses on the end of that second car. So recall that a set of parentheses is the method invocation operator. Whether you realize it or not, you're calling a method whenever you create a new instance of this class. This method is referred to as a constructor, and it allows you, the developer, the option to write some code at the moment of instantiation, that moment when a new instance of your class has been created. So constructors can be used for any purpose, but they're typically used to put that new object that you just created an instance of into a valid state, meaning that you can use it to initialize the values of properties of the object. So a quick example here. Let's say that you want to create a constructor that would set the properties of car whenever it's created, so to some default values, so that it's ready to be used right after you create a new instance. So we can do something like this here. In fact, let me go ahead and add one more property here. Prop tab double original price. All right, and so here what we can do is go public car, and then you could load this from a configuration file, database, or whatever you have. I'm just going to hard code it in this instance. Great. So I'm going to do something like this dot. And we remember what the this keyword does, gives you access to the new instance, or to the instance that you're currently working with. So this.make equals Nissan. So whenever you create a new instance of the car class, automatically it's going to set the make property to a Nissan. Admittedly, that doesn't make a whole lot of sense right here, but I'm just showing you the technique that you would use, not the rationale in this case why you would want to do that. All right? Okay. The next thing I want to talk about is overloaded constructors. Just like you created an overloaded method by changing the method's signature, in other words, the number of and the data type of the input parameters, you can do the same with the constructor method. You can create an overloaded constructor. So let's add an overloaded constructor to our car class. And I'm just going to create a second method like so. Notice I'm not using the this keyword this time. Okay. So now whenever we attempt to create a new instance of car, let's do that here. Notice that I get two versions of the method. I'm using my up and down arrows on my keyboard. So the first method signature takes no parameters, and the second takes 4 input parameters. So this helps us put the new instance of the class into a valid state to begin with. All right, so let's go ahead and create using this. So we'll just do Ford Escape 2005 white, like so. Great. All right, so what if we were to create an overloaded version of the method that conflicts with our existing overloaded constructors? So let me do this. I'm going to take this, I'm going to copy it, and I'm going to paste it here. And I'm going to say, call this some other input parameter, like so. Okay. And we'll even go some other input parameter, like so. Okay? All right, well, whenever we attempt to actually build our project or run it, the compiler will stop and say that this version of the method conflicts with our existing overloaded constructors. So type object lifetime.car already defines a member called car with the same parameter types. All right, so it fails because the car class already defines a member called car with the same parameter types. The method signature has to be different. The name of the first parameter changed, but its data type did not change, and that caused the compilation error that you see on screen. So the parameter names don't affect the method signature, just the data types and the number of parameters. All right. So again, we used an overloaded constructor to initialize values of our new instance. Let me get rid of this. Right here. We could create as many different overloaded versions of our constructor, or any method for that matter, that we wanted to make it more convenient to call by the consumer of that method. All right. So what happens if you don't create a constructor? I mean, in our previous example, in the previous lesson, we didn't have any constructors. We didn't even talk about them. So what happens when you don't create a constructor? Well, nothing really happens. Basically, a default constructor with no input parameters and no body will be created automatically for you. So it'll be essentially the equivalent of doing that, okay? And it'll be created for you, and it'll do nothing, right? So let me paste back in what I just stole. All right, like so. Great. All right, so you still, no matter what, will have a constructor, it just won't do anything. The implicit default constructor has no input parameters and no method body. It's actually just generated for you at compile time. Of course, as we've just seen, by defining one or more constructors, you're merely taking control of the process of instantiation. All right, so let's move on from constructors. Let's move on from talking about overloading. Let's talk about the keyword static for just a moment. We've seen this at play in every application that we've built here in the static void main, for example. So many times classes that we're going to work with related to building .NET applications don't require you to create a new instance of them to actually work with them. So you might recall seeing the following. Do you remember array.reverse and we passed in my array? Or remember we used datetime.now and I said it's a static property at that time? Or string.format, how does that work? Okay, or we use console.writeLine. We never created an instance of console, but we're able to use the write line all over the place. Well, how is that even possible? They just kind of pop out of nowhere and we're instantly be able to use them and work with them and utilize them. Well, it's only possible because when Microsoft created those methods and those properties, they defined them as static, or they defined the entire classes as static classes. And you can create your own static methods and classes as well. So again, our objective here at the outset is just to help you utilize the .NET Framework class library. So just know that some classes that you'll want to work with will require you to first create an instance of a class, and others will be available as static members right off the bat. In other words, their static methods will be available to you without requiring you to create an instance of the class first. But just so you can see how this works, it's really simple. You just add the C# keyword static. So in this case, let's go back to the car class here, and let's create public static void my method, all right? And it won't really do anything. And then we can use it in our project like so. Now I'm not going to use any of the existing my car, my other car, my third car, any of those sorts of things. We're just going to call car dot, and notice it shows up, my method shows up as a static method without creating an instance of car. Okay? Now what's a bit more complicated is why you might want to create your own static members on your classes, and that might require a longer discussion of design patterns and coding heuristics. Again, I just want you to know what they are for now and how you'll encounter them when working with the .NET Framework base class library, and you can pick up the rest a little bit later on whenever you're designing your own code libraries. Not really important why you'd use them just yet. Just know that they're in use and there's a reason, and we're not going to talk about it in this series. Okay, so in this lesson we talked about the lifetime of an object, including what happens when there are no more references to an object in memory, and how the .NET Framework runtime employs the garbage collector feature to remove those objects at some point during the execution of the application. We looked at constructors and overloaded constructors to put the object in a valid state before we use it. We also talked about the static keyword and how to use it to create essentially utility methods that are available anywhere at any time without having to create instances of classes first, like we've seen and used many times up to now with the various utility methods in the .NET Framework class library. All right? So if you don't completely understand the notion of static, I'd recommend that you watch that portion of this video again. That will become crucial. Again, it's just available without having to create an instance of the class. We're not going to talk about why. It just is for now. Also, make sure that you understand the notion of overloading. We've seen it at work. And to create it, how do you create an overloaded version of a method? Right, you just make sure that the method signature is different. The method signature is the name, but specifically, it's the number and the data type of each of the input parameters. If you have that under your belt, I think you did really well with this lesson. You can move on. All right, so we'll see you in the next lesson. Thank you.